Hey everyone, welcome back to Coded Row. Today we're diving into something super powerful in Unreal Engine 5, the Gameplay Ability System, or GAS for short. Whether you're new to Unreal or have been around for a while, GAS is a tool that can level up your game development skills by giving you a structured way to handle abilities, effects, and more. So let's go ahead and get started. So I'm going to select games and create a brand new project, a third person, and I'll start from a C++ class. Don't worry, we will create blueprints, but Gas does start with quite a few C++ stuff, and don't be intimidated. It's actually pretty simple to set up, and I'm here to help you every step of the way. So I'm just going to call this project something like Gas Example. This will be a very introductory level Gas tutorial, and let's hit create. So what exactly is Gas? In simple terms, Gas is a framework that helps you manage complex abilities in your game, like spells, combat skills, and buffs in a highly efficient and scalable way. It's built directly into Unreal Engine and is designed to work seamlessly in both single player and multiplayer games. Think of Gas as a way to create, activate, and manage abilities while keeping everything organized under the hood. It handles things like cooldowns, costs, and effects, basically all the heavy lifting, so you can focus on the fun stuff. In my opinion, it's the best way for a solo indie developer to create a massive AAA type game. Better than any plugin because you know that this will be consistently updated by Unreal, where a lot of plugins that I've worked with in the past, they kind of go dark on me. So, first, as my project launches, we'll head over to Edit, Plugins, and we're going to look for Gameplay Ability, like so. So, I'll enable Gameplay Abilities and hit Restart. And with GAS enabled, we'll start by creating a custom ability system component, and this component will be the backbone of your character's abilities. So in order to create the ability system component, first I'm going to head over to my C++ class. Inside my gas example, I'm just going to right click and create a new C++ class and select all classes and look for the ability system component like so. So this class will inherit from our ability system component, and I'll hit next, and I'll just leave the name as my ability system component, and I'll hit create class. Now this is going to launch my Visual Studio and whatever your preferred IDE is to debug and code with Unreal Engine. And if this comes up, I'm just going to select reload all, and you'll see that my ability system component.cpp and .h, or my header file, is now open. But another thing I actually want to open is the gas example character. I named this project gas example, but I do want to open my gas example character. So we need to add the my ability system component into our gas example, into our character. So at the very bottom of my character header file, I'll scroll all the way down until I'll see this public underscore force line class for the camera component. This is where I'm going to add my ability system component. So I'll just create a comment here that says ability system component. So in the next line, I'm going to add a U property. And the U property macro is used in Unreal Engine to expose class members like variables to the Unreal Engine editor, blueprint, and other parts of the engine. It allows you to control how these variables behave within the editor at runtime. And then in parentheses, I'm going to type in visible anywhere, blueprint read only, and category is equal to abilities, just like this. So let's go over which each of these do. So the visible anywhere just is a specifier indicating that this property is visible in the Unreal Editor in all contexts, like in Blueprint Editor in the Details panel, but it can't be edited during runtime or in the editor. And this is useful for properties that you want to inspect but do not want to allow changes to. So we're probably going to use this for components or variables that are automatically managed by our class, where changing them could break functionality. The blueprint read only is a specifier that allows the property to be read in blueprints, but not modified. You can access this variable within blueprints, but you can't change its value. And this is good for us when we want to expose certain data or components to blueprints for reference or logic purposes, but want to prevent them from being modified. And the category equals abilities is just a group. So it just groups the property under the abilities category in Unreal Editor's detail panel or the blueprint editor. Categories are used to organize properties in the editor for easier access. And now in the next line, I want to add the class, which is going to be our U my ability system component, and then an asterisk, the ability system component. And don't forget to add that semicolon or else you will get a ton of errors. So this class, UMyAbilitySystem component, this is just a pointer to an instance of the UMyAbility component here, or UMyAbilitySystem component. And the ability system component is the name of the variable that holds the pointer. So this variable is going to be holding this. And we'll be using the ability system component to interact with the gas, such as granting abilities, applying effects, or checking cooldowns. Now let's go ahead and initialize this constructor in our C++ file. So I'll head over to my character C++ file, and now I need to initialize this in our constructor. So at the bottom of my constructor, I'm just going to initialize the ability system component, and now I'm going to grab that ability system component is equal to create default subobject. And we're going to look for that UMyAbilitySystem component, and then text will be the ability system component. And I'll make sure the spelling is correct, like so. And then I'll add a semicolon at the end. This ensures whenever an instance of a gas example character is created, when the game starts and the character spawned, the ability system component is also created and ready to use. So now let's create our first ability. Abilities in gas are defined as gameplay abilities, and they can be anything from a jump to a fireball spell. So in the top of the gas example of my character CPP file, I'm gonna add my include or hashtag include, and I just want to include our my ability system component.h. So in quotes, I'm just gonna add that my ability system component.h like so, and then I'll hit Control S to save. And after adding that hashtag include, I'm just gonna head over to my project name, click on this drop down source folder, drop down the project folder name again, and double click gas example build.cs or .build.cs file. And at the end of this public dependency module names, I'm going to add a few things which are going to be in quotes. I'll add a comma here. I'll add a comma after my enhanced input. And in quotes, I'll add gameplay tags and then a comma. And then I'll also add gameplay abilities. That has to be one word. And then I'll add gameplay abilities, comma, and then I'll add gameplay, in quotes, I'll add gameplay tasks. And now I'll go ahead and rebuild and click play to launch my project like so. And you'll see that it says my ability system component down here in my C++ classes folder. Now let's create our first ability. Abilities in gas are defined as gameplay abilities, and they can be anything from a jump to fireball to a storm and so on. So I'm going to right click while I'm in my gas example C++ classes folder, create a new C++ class, and under all classes, I'm going to search for something called gameplay ability. So while gameplay ability is selected, I'm going to click next, and I'm going to call this something like my jump ability. And then I'll hit create class. And now this will open up. And over in my jump ability.header file, I am going to edit my code. So under this class gas example API, under my generated body, I'm just gonna create some spaces and add a public. And I'm gonna comment here that says override the activate ability method. We are going to add a pretty long line. And bear with me, but I'll try to explain every step of the way. So first, I'm going to start off with virtual. And virtual keyword indicates that this function can be overridden in a derived class. So in C++, when a function is marked as virtual, like we're writing here, it allows subclasses to provide their own implementation of this function. And then I don't want this to return anything, so I'm going to add void next. And now we're going to name the function activate ability. And now after void, we want to call the name of the function that's provided by the gameplay ability class. And this is activate ability. And now let's create a couple parameters. So I'm going to create a constant f gameplay ability spec handle and just call this handle. So this is the handle to the specific instance of the ability being activated. It uniquely identifies which ability is being used, allowing the system to differentiate between different instances of abilities, even if they are the same class. And I'll add a comma. And now I want to make another parameter. So I'll create another const f gameplay ability actor info with a star or an asterisk and call this actor info. And this provides information about the actor that owns the ability, such as the character or the pawn using the ability. It includes pointers to the owner, the avatar, typically the character, or other useful information. And now create another parameter called const f gameplay ability activation info. And this variable will be activation info. And this struct provides information about how the ability was activated, including details like whether it was triggered by an input or a gameplay event. It helps determine the context of the ability's activation. And now another parameter is going to be our const f gameplay event data with an asterisk, and we'll call this trigger event data. And this parameter is optional and provides additional data about the event that triggered the ability. So for example, if an ability was triggered by an external event like an enemy hit, this struct might contain information about that hit. And then I will close my parentheses like so, and then I will just type in override and add a semicolon, and that finishes it. And the override keyword is used to indicate that this function is intended to override a virtual function in a base class. So it's good practice in modern C++ because it helps the compiler catch errors. If, for example, the function signature doesn't exactly match the one in the base class, if there's no matching function in the base class, the compiler will generate an error. So I'll hit Control Save. And now I'll move over to myjumpability.cpp. So I want to include our game framework from our character. So I'll type in include game framework slash character.h. And then I also want to include ability system component.h as well. And now I want to create a function. So in our myjumpability.c++, I'm going to head over to this myjumpability.h and copy that really long line that we created here. And I'll start from the activate ability all the way to the end. And I don't need this override, and I don't need the override. So I'm just going to copy its activate ability to the end like so. And make sure you include the parentheses. So I'll hit Control C to copy, and I'll paste this right here. And before this activate ability, I'm going to add void, because we're not returning anything, u, and then the name of the file. And my jump ability, and then colon, colon. And I spelled mine wrong. My jump ability, colon, colon, and then let's do an open bracket over here. And now you see our error messages went, or our red squiggly lines went away. And what this does, so now we're going to be defining our activate ability method, which is going to be declared in our u or my jump ability. And this is important because this is going to be defining the core behavior of our ability. So now let's go ahead and actually just define this behavior. So I'm going to add a comment that says check if the actor has a valid character reference. So we're going to be basically doing kind of like a branch check with an if statement. So if a character star character is equal to cast a character, I forgot the A in front of it, cast a character, and then in parentheses, I'm going to do actor info, avatar actor dot get, and opening curly brackets because this is the name of a function. And then I will just close this parentheses. So you see there's 3 layers of parentheses, one for this get, one right here next to the actor info, and one next to a character. And basically, if this is true, then I want to make the character jump. And then I will do character and call that jump. And then I will end the ability. And by ending the ability, I need to call the end ability and pass my parameters that I've set up here. So I need to pass that handle, actor info, activation info, and I'll set true, comma, false, and add a semicolon at the end. So let's go over this briefly. So the handle, actor info, and activation info are parameters that are passed to end ability to maintain the context of the ability. And the true Boolean indicates that this ability was successful, and the false Boolean indicates that there was no need to broadcast the abilities end. And the false Boolean indicates that there was no need to broadcast the abilities end to others like in multiplayer games. So the reason why end ability is important is because it properly terminates the ability, freeing up any resources it might have been using and ensuring the system is aware that the ability has finished executing. So this is necessary to maintain the correct state of abilities within GAS. And I'll hit save to save this CPP file. And now that we are finished with the myJump ability, .header and .c++, I want to go to the gas example character.cpp and include this as well. So I'm going to do hashtag include and then in quotes my jump ability.h and I'll hit save. So now I'll scroll down under the setup player input component and under where it says setup binding action, under where it says setup action bindings under my looking, I'm just going to create a couple spaces and actually add my ability system component over here. So I'll just create a comment that says ensure the ability system component is valid and bind it to the input. So if ability system component and player input component is true, then in curly brackets, I want to do ability system component. So this if statement is checking if ability system component and player input component is valid. And basically, if this is valid, we're going to call this function, which calls a bind, which is going to call this. And this call binds the ability system's input handling to the player's input component. Specifically, it maps input actions like pressing a key to the activation of gameplay abilities. And I'm going to leave this parentheses open. And in quotes, I want to do confirm, cancel, EGEAS, so the eGas ability input ID. And then I also want to call a static cast. So let's first go over the ones above it. So the F gameplay ability input binds is a struct that specifies how different input actions are mapped to the ability system's internal mechanics. It's defined how input commands like confirm and cancel are linked to ability activation. And then we'll add the actual inputs, such as confirm, cancel, and the eGas ability input ID. So this string represents the name of an enumeration, or an enum, that defines the different input IDs used by the gas that's used by gas. And the enum, eGas ability input ID, would typically include values for different types of inputs such as confirm or cancel. In the static cast that we're going to add now, so the static cast of int32, eGas ability input ID confirm. So this will convert the eGas ability input ID enum value to an integer, int32, which then passes into the ability system as an ID for the confirm input action. And now let's create the same thing for cancel. So I'll just copy paste this, and at the end, I'll do cancel. And I need to close off this parentheses because it's not actually closed, and one more time to close off this parentheses over here. And then I'll add a semicolon afterwards. And you'll see I have a couple red squiggly lines under my eGas ability input ID. So in order to fix this squiggly under the eGas ability input ID, I'm going to head over to the characters.header file. And under my declare log category external and above my new class, I'm going to define the eGas ability input ID enum here in the header file. So I'll create a U enum of a blueprint type, which is going to be an enum class called eGas ability input ID. And I'll make this a uint8. And I'll open some curly brackets and it will automatically add the semicolon at the end. And I'm just going to define none, which is going to be a umeta of a display name. And the display name will, of course, be none. And then I'll add one for confirm. And then I'll add one for cancel. And this looks good to me. And now something that I like to do is just expose my abilities to my character via blueprint. So I can just add it from there and activate it really easily. So in my gas example character.cpp, I'm going to scroll down to where it says void a gas example character begin play and call the base class super begin play. So this is already in here by default, but I just want to add into it on begin play. So if ability system component, so if we have the ability system component, then I want to grant each ability in the default abilities array. So I'll open in curly bracket here, and inside these brackets, I'm going to add this if ability statement. So if we have an ability, then ability system component give ability to our character and ability, which is going to be a static cast of our eGas ability input ID confirm and this. So this is the skill that we're going to be using as long as we have the ability in our array. I need to add an array to store default abilities to be granted to the character. So as discussed before, I'm just going to write a U property with the edit anywhere blueprint read write and category equals abilities. And then I'm going to create a T array, which is a T subclass of U gameplay ability, and it'll be listed under default abilities in anything that contains the ability system component. So I'll hit compile, save, and launch my project. And now that my project's open, what I can do is just in my content folder, I'm just going to right click and create a blueprint class that's going to derive from the my jump ability. So I'll select this and I'll do BP underscore my jump ability. And when I create this and double click this, you'll see on the right there are a bunch of tags I can assign it to. So if I wanted to, for example, attach this to an ability tag, I can go ahead and click this plus button and I can name this something like ability.jump, just as an example. And the source will be default gameplay tags.ini, and I'll click add new tag and select it here. And there are a bunch of other things we can do, and we'll go over that in future tutorials. So I'll go ahead and save this. And now back in my BP third person character class, I have this ability system component that we added earlier anyways. But when I select my BP third person character, I'm going to look for the tag we created in C++, and we called it default abilities here. So I'll just search for that in my details, and under an abilities tag, you'll see a category called default abilities, and I'm just going to add that BP my jump ability in here like so. So I'll hit compile and save, and what I want to do is actually try this out. So I'm going to right click and look for a debug key, and let's do F in this case. And when F is called, I want to print string, and this is going to be F button clicked. And then I also want to add another blueprint that's only related to, and I want to add another blueprint, and I'm going to look for get gameplay tag. And now I'm going to drag out this string and look for activate ability by, I can do class or tag. So the first one I'm going to do is by the class. So it's going to automatically target our ability system component. And for the inability to activate, it's going to be the BP underscore my jump ability. So I'll hit compile and save. And now when I head over to my third person map and I'll click F, you'll see that our character is jumping. And on the top left, it says F button clicked. And now let me break this pin and try to do it by the actual tag. So you'll see that in our BP my jump ability, in class default, we have the ability tag called ability.jump. So if I go to my BP third person character, I can try to activate the ability by tag. And this tag, I'm actually just going to promote it to a variable called jump tag. And I'll select my jump tag and compile it. And for the jump tag, I'm going to set this to the ability.jump like so. And now when I hit compile and save and actually try it out, you can see that it's working by my tag as well. In conclusion, the gameplay ability system, otherwise known as GAS, in Unreal Engine is a powerful and flexible framework that allows developers to create complex gameplay mechanics with ease. While we started with a simple example by implementing a jump ability, the depth of GAS extends to far beyond basic actions. And through this tutorial, we explored how to set up the ability system, manage abilities through blueprints in C++, and troubleshoot common issues. In future tutorials, we'll delve deeper into GAS, exploring complex abilities, attribute systems, more gameplay tags, and networking and replication. If you found this tutorial to be helpful, please subscribe to stay updated on future lessons, where we will build more advanced abilities and gameplay mechanics. Thank you for joining me in this learning journey, and I look forward to creating more exciting elements with you in the future. Don't forget to like, share, subscribe, and stay tuned for more in-depth Unreal Engine tutorials. Thanks for watching Code to Row.